This video is going to review thermal energy and how it's transferred. By the end of this video, you should be able to compare and contrast the transfer of thermal energy through conduction, convection, and radiation. Let's first look at conduction. Conduction is the transfer of energy by colliding particles. So as objects are heated up, we know that objects are made of small particles. As they increase their heat, they actually start moving more, and they end up colliding with their neighbors. And as they increase their temperature, they then collide with more of their neighbors, and it expands out and out. So you can imagine that an object made up of materials can have heat energy, this thermal energy, moving through a substance by these colliding particles. So if heat starts on one side of material, especially if it's a good conductor, such as metal, it can spread over an entire area. The textbook uses this graphic to help show this phenomenon. We've got the heat from the Bunsen burner on the left-hand side of our object, and that heat is being transferred to the neighbors that aren't quite moving quite as fast. But as they heat up, the kinetic energy increases, and they become more have more thermal energy, and then they end up impacting their neighbors. So if this is a piece of metal, you can see how conductive it could be. Convection is another way we can transfer energy in substances. Convection is going to occur in a fluid, which is different than a solid. Fluids are able to move. And because they can move, it depends on the direction of that fluid's movement. We know that objects like to go from where it's warm to where it's cool, just based on fluid movement. For example, if I were to look at a beaker on a Bunsen burner, the water near the bottom would be hotter than the water at the top. So, the water will rise in the beaker, cool down, and then fall. That is a kind of convection current. Heat transfer creates this current inside fluids. This has lots of important implications in nature. Our weather system is controlled by convection currents. The third way we transfer thermal energy is through radiation. And radiation is electromagnetic waves. The sun produces quite a bit of electromagnetic waves. It could include light, infrared, ultraviolet, other kinds of rays such as gamma rays. As you can see, all emitted probably knit up by the sun. Now this becomes important because we know that radiation can impact different objects. So if we had a white sheet of paper and another sheet of paper that was darkly colored, right? We know that the one that is darkly colored will have a higher heat because it will absorb more of that energy, that radiant energy from the sun. One last thing to think about when you talk about thermal energy is how do you keep it from escaping? So in order to do that, we use insulators. As you can think of an insulation in a house, we use that insulation to keep the heat from escaping. So we make sure we have doors and windows that are also airtight to prevent heat loss. There are lots of applications for insulators, such as clothing and animals. We can think of blubber and fur. In thermoses, we can see them to help keep our liquids cool or warm, depending on the temperature that we want. So as you can see, there are three main ways that we can transfer energy. Thermal energy, conduction, convection, and radiation. And we control that loss through an insulator.